Good morning, students. Chapter 6, Electromagnetic Induction. Yes, we will see extra question. Here you are given two co-planar square loop. One having side capital L, another having side small l, and yes, their center, their midpoint coincide with each other. Okay, you are given one condition. Capital L is very greater than L. You have to find mutual inductance of this system. See, I am assuming current I is flowing. Current I is flowing in this large coil. Okay, let current I is flowing in this large coil. Okay, so yes, I am assuming let current I is flowing in large coil. Okay, so yes, due to this coil, magnetic field produces, that is linked with this small loop, and with this small loop, magnetic flux is linked. So yes, with the help of that, we can find easily. Okay, see now how to find this. This square loop, small square loop, it is placed at center, and as L is very greater than L, we can say magnetic field produced due to this large scale at center is equal to magnetic field on this square loop, is equal to magnetic field on this square loop. So first of all, we have to find magnetic field due to this square loop. Square having side L. Square means having side L. See, I will draw one wire like this. It is one wire. Current flowing is in this direction. And yes, center is here. This side is, it is L. This side is, it is L. So yes, it is, I have to consider wire of finite length. Wire of finite length. And yes, in case of wire of finite length, how to find magnetic field? What is equation? See, here it is. Here it is. What is equation? Equation is B is equal to mu 0 I upon 4 pi y sin theta 1 plus sin theta 2. See, here it is. This distance, it is considered as y. This angle, theta 1, and this angle is considered as theta 2. Yes or no? If you remember this case. Okay. From this wire, at this point I have to find magnetic field. So it is perpendicular distance y. Connect end with this point, angle theta 1. Connect end with this point, angle theta 2. As it is square, obviously this angle theta 1 and theta 2, they will become 45. Yes or no? Yes, because it is square. In case of here, it is square. In case of here, it is square. This angle is 90, so this angle will become 45. It is 90, so obviously this angle will become 45. Yes or no? So here theta 1 and theta 2, they are 45. Theta 1 and theta 2, they are 45. Now see here. For this wire, also angle theta 1 and theta 2 will be 45. Distance will be y, and previous distance y is equal to, it is L by 2. Here distance y is equal to, it is here distance y is equal to, here theta 1 is equal to, theta 2 is equal to 45, and distance y is equal to L by 2. Yes, this distance is L by. Okay, yes. Now due to another wire, again we have to find magnetic field at this point. Square. So from this geometry of figure, we can say theta 1, theta 2 and y will be same. For this wire, same. For this wire, it is same. But what about direction of magnetic field? What about direction of magnetic field? Magnetic field produced due to this wire. Hold wire in right hand. It is thumb. It is thumb. Okay, in this direction of current. This side, fingers are going inside. Fingers are going inside. So magnetic field due to first wire is inside. Then for this second wire, current is going in this direction. Point is below wire. So below wire, fingers are again going inside. So yes, magnetic field is inside. Due to this wire, current is in downward direction. Current is in downward direction, and see current it is in downward direction. So again, this side, fingers are going inside, so magnetic field inside, and due to this wire also magnetic field inside. So yes, due to each and every wire magnetic field is inside. Okay, due to all wires, magnetic field produced is in same direction. So how to write? So yes, therefore, okay, resultant magnetic field at center B is equal to 4. Why 4 multiplied? Because we have total 4 wires. Okay, and yes, they are identical. That's why it is mu 0 I upon 4 pi y sine theta 1 plus sine theta 2. Okay, so yes, P is equal to, here it is 4 into mu 0 I 4 pi. What is value of y? L by 2. Here it is sine 45 plus sine 45. Okay, so see this 4 cut, this 2 we can write in numerator. So B is equal to, it is 2 mu 0 I upon pi L. Sine 45 1 upon root 2. Sine 45 1 upon root 2. So yes, I can write it is 2 upon root 2. Clear about this? Again, sine 45 1 upon root 2. Sine 45 1 upon root 2. So 1 upon root 2 plus 1 upon root 2, it will be 2 upon root 2. Clear about this? So it is magnetic field. Now we have to find flux linked with small coil. Okay, so yes, flux linked with small coil. Okay, that is phi is equal to, what is equation? AB cos theta. What is equation? It is AB cos theta. A, flux linked with small coil. So area of small coil, that is L square. Yes, L square. B, that is magnetic field. Here and see 2 into 2, it will be 4. So it is 4 mu 0 I. 4 mu 0 I divided by it is root 2 pi L. It is root 2 pi L. What about cos theta? See, theta is angle between area and magnetic field. Magnetic field is perpendicular going inside, that we have discussed. Okay, magnetic field is perpendicular going inside. This square loop is also in plane of chord, so its area vector is also perpendicular. So angle will become 0. So So here it is cos 0. And you know what is value of cos 0? Cos 0 is equal to, it is 1. So it is equation of 5. Now we have to find mutual inductance. Inductance means flux upon current. Inductance means flux upon current. So make phi upon I as subject. Then phi upon I is equal to, it is 4 mu 0 I L square upon root 2 pi L. Then this phi upon I is called mutual inductance. That is M is equal to 4 mu 0 I L square upon root 2 pi L, or you can write 2 root 2 mu 0 I L square upon pi L. Okay, it is equation of mutual inductance. Okay, so yes, it is one question that we have discussed for 2 concentric rings. Okay, if we have 2 rings R1 and R2 having radius is R1 and R2, then what is mutual inductance? It is similar question. But yes, this one you have to find this magnetic field. Okay, now next question. See, you are given one figure. Okay, you have to find equivalent inductance between points A and B. Now, these inductors are in which connection? So see, first of all, yes, as this point A, I am assuming this point is X and this point B is Y. Okay, as we have to find equivalent inductance between A and B. See, A, its common point is Y. B, its common point is X. Now see, this first inductor, it is between A and X. This first inductor, it is between A and X. Yes, it is between A and X. This second inductor, it is between X and Y. It is between X and Y. And this third inductor, it is between Y and B. It is between Y and B. So yes, these three inductors, they are in parallel connection. They are in parallel connection. And for parallel connection, equivalent inductance 1 upon L is equal to 1 upon L1 plus 1 upon L2 plus 1 upon L3. Okay, and yes, therefore it is 1 upon L is equal to 1 upon 3 plus 1 upon 3 plus 1 upon 3. It is 3 upon 3, and therefore L is equal to, here it is 100. L is equal to, here it is 100. Clear about this? So yes, it is parallel connection of inductor. See, we have discussed connection of inductor is like connection of resistors. Okay, what is series connection of resistor? What is parallel connection of resistor? Formula. Okay, formula. See, formula. Clear about this? Now we will see next question. See. Now next, see, here it is one condition. In this case, in this question, we will see different cases. Okay, what is given? You are given one square plate having side L. It is moving with uniform velocity v, but such that in this half region, magnetic field is perpendicular outside, and in this region, magnetic field is perpendicular inside. Then in such case, you have to find induced EMF in coil. Induced EMF in coil. Now see, first of all, there are 4 wires, 1, 2, 3 and 4. Velocity is in this direction. Velocity is in this direction. See, first point that you have to remember. If it is magnetic field, conductor is placed perpendicular to magnetic field and its velocity is also perpendicular. These 3 quantities are perpendicular to each other. Yes. So as it is conductor, we know that force is acting on charges. Conductor is made up of positive charges and negative charges. So when conductor is moving, means charges are moving. So on moving charge, what is force acting? F is equal to Q V cross B. F is equal to Q V cross B. And force acting on positive charge, B in this direction, B in inside direction. So force acting on positive charge is in upward direction, and force acting on negative charge is in downward direction. So here negative charge is accumulated, here positive charge is accumulated. Means it becomes positive and it becomes negative end. Positive terminal, negative terminal. Clear about this? Okay. But if yes, it is magnetic field. It is magnetic field perpendicular like this. Okay, and rod is moving like this. This wire is moving like this V. Then yes, in this case, as this thickness that is perpendicular to velocity is less, EMF is not induced. In this case, EMF is not induced, and in this case, EMF induced is BLV. If its length is L. So how to remember? See, this conductor, see, magnetic field is going inside. Magnetic field is going inside like this, and it is wire. So this wire cuts this magnetic field. So whenever wire cuts magnetic field lines, EMF is induced. But what happens in this case? Magnetic fields are like this, okay, and wire is moving like this. So it will slide. It will not cut magnetic fields. So here in this case, EMF is not induced. Okay. Similarly, if you remember, okay, horizontal component of Earth's magnetic field, it is from south to north. if wire is falling such that it is in east-west direction, it is in east-west direction like this, then see, it will cut horizontal component of Earth's magnetic field, so EMF is induced. But it is falling in north-south direction, then magnetic field lines, okay, they are not cut. And if they are not cut, flux is not changed. Clear about this? So whenever object cuts magnetic field lines, flux is changed, EMF is induced. So see, out of these 4 wires, for this wire EMF is not induced, for this wire EMF is not induced. Clear about this? Yes or no? Yes. So in these 2 wires EMF is induced. In this wire, yes, it is similar condition. It is similar condition. Yes. So this terminal will become positive. This terminal, this end will become negative. While this side, see, length is same. Velocity's direction is same. Only magnetic field is reversed. So hello, be smart like me, okay? Here EMF is induced such that as magnetic field is in opposite direction, obviously in this case it will become negative and then it will become positive end. With the help of this, see here, if magnetic field is outside, velocity in this direction, magnetic field outside, then force acting on positive charge is in downward direction and force acting in negative charge is in upward direction. So yes, it will become positive, it will become negative. Okay, so yes, how to draw this figure? Again, I can draw this figure like this. Like this. Okay, its EMF is E, its EMF is also E. Yes? Yes or no? Yes, its EMF is also E. Okay, now which connection is this? Series connection. But series connection helping or opposing? You see, plus minus. So it is helping condition. So in this helping condition, resultant EMF E dash is equal to this E1 plus E2. It is E1, that it is E2, it is E1 plus E2, it is BLV plus it is BLV, so it is 2BLV, so it is plus 2BLV. If magnetic field on this whole square root is same, that is only in one direction, then magnetic field EMF induced will be 0. EMF induced will be 0. Okay, because it becomes positive, it becomes negative. It becomes positive, it becomes negative. Then opposite condition, and in opposite condition, resultant EMF will be 0. Clear about this? Okay, so yes, this point you have to remember. Yes, I will write one short note, that is BH, that is horizontal component of Earth's magnetic field, that is from north to south direction. If wire which is in east to west direction is falling down, then yes, EMF is induced. But if wire in north-south direction is falling down, okay, then EMF is not induced. So this extra point you have to remember. Clear about this? So yes, this is it for today.